doing this. Really, you just want the numbers, and I guess they're not the. Oh my goodness, nothing's working right. All right, so that's not gonna work either. Okay, so I'm seeing the only way really to do this is manual entry, which will just take a little bit here. So I've got something else open. I'm gonna enter the data manually, and then we'll talk about what to do because we need some sort of a graph. Maybe you could look and see what kind of graph they're looking for.
What kind of graph?
Yeah, maybe you could look through the lesson and see what kind of graph they're asking for.
Okay. Let me just look in the lesson. It says that it doesn't matter what kind of graph or data table we use. Oh, you want the graphs, not the table. I'm
When I
sorry.
look at when I look at his or her feedback, it mentions very specifically that they're looking for some sort of a graph. Um,
I
I can
think
give
they
you the
meant the
answer,
data table.
right? But what kind of graph are they looking for? Remember we studied a bunch of different types of charts that might make sense here. See if there's any
I think
words to that.
it says here, since you're not actually doing this lab, here's the data you'll be adding to your data table. I think she just wants us to use the table she provided in the lesson.
I agree, but what kind of graph are we making? That's what I'm trying to get you to
I
answer.
I don't know. It doesn't
Like,
show it
can
anywhere.
we use well, this is where you have to think back to what we were doing before, which is like, is it okay to use a bar chart? Is that what they're looking for?
Hmm. Right, because in a previous we had to use a graph that had Oh, there are the graphs. A line graph. We have to use a bar graph. No
Bar
wait,
graph's not the
no.
right answer.
Yeah, I'm sorry. I meant a
Uh,
line graph. A line graph would work because of all the numbers.
yeah, line graph is the best choice.
All
So
right.
this is the reading number. So this is trial 1, trial 2, trial 3. These are um, the milliliters and then the temperature. So what I'm going to do here is graph these in another window. Let's see if I can even get this to do it the way I want. Insert, let's see here. We want a line graph, some sort of a line graph. Yeah, okay. That looks pretty good. All right. Um, what do you think the title of the graph should be?
What the title of the graph should be?
Yes. Like what are we graphing in this table? What are we
Like
graphing here?
the heat of the water,
The temperature of the
the
water is on the
temperature,
x-axis, yeah.
and then like let me think. So besides the fact it also mentions like I'm you know the temperature
What
of water, and then I don't know what the second one is.
it's the volume, the milliliters,
Oh, get the volume in the cylinders,
right? So what is changing each time? What is changing in each trial? What
the
trial 1,
temperature.
trial 2, trial 3? Right, but like what is the difference between the trials, if any? Maybe go back and look at the description of the steps. If you're looking at the lesson, where it says materials and methods, there's the actual steps. What
Okay.
I would do is look at those steps and in your own words, answer what it is that you are, what are we doing in your own words here?
Okay. We're heating up the water.
Okay.
We then put the water in a cylinder. We then place the cylinder in a refrigerator.
Okay.
And then we measured the water every 10. degrees Celsius to see if it changes temperature.
Okay, so tell me your own words about that second part, like a title. What's a title that describes the refrigerator part?
The okay, I'm trying to think. The difference of temperatures and I don't know.
Keep going. You're almost there.
Oh yeah.
Small words.
Okay.
Yeah, tell me what happens if something goes in the refrigerator.
It keeps it cool.
Okay, so it's the cooling effect or something.
The cooling
Cooling
effect of temperatures.
cooling of water,
That works
so-
too.
something like that. Okay. And then we format legend. Um so so this is the result of that. This is kind of your graph here. Do you think that will be acceptable?
Yes.
Okay. All right. Anything else that we need to revise for this lesson?
No, I don't think so. I think what we have, well, I'm gonna do later today is to um put everything in the lab format that she wants, submit it, and then hopefully we get a better grade.
All right. So we also need to explain whether 5, 6, 7, 8, 9 are direct or um, inverse variation. So let me briefly describe what direct variation is. So direct variation, uh, it's when the quantities move in the same direction. So it's basically like increase, comma, increase, or decrease, comma, decrease. And so an example of that is like as one thing increases, you want more of another. And then inverse variation is that they move in opposite directions. So as one thing increases, the other decreases. Or as one thing decreases, the other increases. That's opposite direction. So
I
let's
see.
look at question 5 in in the thing there. The question 5 is John owns a lawn care service. You want to look down at that one. If each of his workers is able to mow the same area of grass per 6,000 meters, describe the relationship between the number of workers and the total area that can be mowed in an hour. So the question is, as you have more workers, can you mow more grass? More workers, more grass or less grass?
Uh, more workers, more or less grass. Well, if you have more workers, you're gonna have less grass.
Think about as think about let's do a different example. Let's
Okay.
say um let's try to think of something that you might be really reasonable. Let's say you're paving a street. Would you want
Okay.
more workers or less workers?
I would want more workers.
You can get more of the street done.
Yes.
So think of the grass. We're not talking about what each worker does. We're just talking about like there's is an infinitely big field.
Oh,
So
okay, okay. So for this, you're at for like more workers, it would have more grass
okay,
because
so
you're getting more done.
that's direct variation.
Okay,
Okay.
I
Now let's look at
understand.
6. 6 says the relationship between number of workers and how long it takes to mow a lawn. So now this is where you have a fixed size in the lawn. So is more workers mean more time or less time?
More workers means more time. Well, Actually, no, it means less time because you finish more done, but because you have more people, it won't take
Right,
as long.
right. So that is inverse variation. See how they go in opposite directions? One goes up, one goes down. Yes, no, maybe.
Maybe, I don't know.
Well, either you do or you don't. Either see
I
that
don't.
more means less, like they're going in opposite directions. More workers is increasing, less time is decreasing.
I see.
It's okay if you don't. I mean, just say
I
so.
don't get it. That I'm saying I see like I understand, but I still don't get it.
Okay, well, if you increase the number of workers,
Okay.
are you increasing the amount of grass cut?
Yes.
Okay, so that's direct variation because they're going in the same direction. If you increase the number of workers, you're decreasing the time to get the job done. If it's an increase followed by a decrease, those are opposite directions. That's why it's inverse. Direct is when they go in the same direction. Direct means increase, increase. Inverse is increase, decrease.
I see.
So we'll try another one here. Discuss the relationship between how fast you drive and how long it takes you to arrive at your destination. Increasing the speed, does that increase the time or decrease the time to get
It
there?
decreases the time.
Okay, so which type of relationship is that? Are those going in the same direction or opposite directions?
They're going opposite directions, so that's
So is
an
that
decrease. Oh, I'm sorry, inverse
inverse
variation.
variation? All right, so if you've got access to question 8, go ahead and look at it. Also put it in the chat if you want to look at that. But go ahead and read that one and tell me whether you think whether that is an inverse variation or direct variation.
Okay, let me just copy and paste question 8 into. Oh, never mind. I was about to send it to you in case you didn't get it. Discuss the relationship between how fast you drive and between how far you travel in a certain time. Um, hmm.
Try to put it into a sentence. As you drive faster, I will, try to finish the sentence in the context of that.
Are they asking like the distance?
Yes.
Oh, okay. Here's what I wrote in the chat, like a sentence that I think would make sense.
But that's not true. You can drive
Oh,
further in the same amount of time if you go faster. So the faster you drive, the more distance you will cover.
oh. Let me just change that then.
All right, so taking a look at my screen there, is that direct or inverse variation? Are they going in
Direct.
this? Yeah, are they going in the same direction or not? They are. So that is direct variation. Okay. So these are this is lesson 4 edits.
It's lesson 3.
Lesson 3. Okay. So let me know where you want us to go from here. I'm just going to save this file and make sure it's all ready for you.
Let's do lesson 6 in physical science. Because that's where we are there. Lesson. I don't want to do any English today. I don't feel like doing English.
Okay. Understood. All right. Let me all right. So go back to okay. So let's go to full lessons, states of matter. All right. Okay. So I shouldn't have closed that. Darn. All right. We need this lab report.
No, not
Uh,
again.
yes, yes, again. All right. So
At least we know what to do this time and not make the same mistake.
this one does say pictures, so I don't know what that means for you, but you'll have to take some
Uh,
pictures.
I'm gonna
No
post this
selfie.
lab report at home.
Usually they usually they want selfies, like they want to see you actually doing the report.
Yeah.
I don't I like understand it, but I mean it's kind of weird to me. I mean, but anyway. Uh Actually, that's a really good use of AI. You could like upload a picture of yourself and then say, create a picture of me, boiling water, and then they'll create a picture for you of that.
I
All right, so
guess.
I got that going. Answer these questions. Let's see here. Introduction. All right, so I guess what I'll do is I'll just start nipping these in before you do the lab. Okay. This is your hypothesis for procedure. I don't know. I think we're gonna mess up the format again because it's like they're giving you a format, but then they're not like then they're saying, oh, put these in the introduction, but is it the answers or is it something else? They could certainly do a lot better job to make it clear. So let's take a look here. In this lab, we will be looking for a difference between what happens when you heat a pot of water with different amounts of ice. Give your current understanding of heating ice water. What do you think the difference will be between half of the pot being filled with water and half the ice compared to half the pot being filled with water and only a quarter with ice? Okay, Ivana, this is where you get to jump in and tell me what you think. I do want you to write a sentence or two. The sentence should say something like, the pot of water with half ice will something compared to the pot of water with quarter ice. So that's like a fill in the blank, and then you have to answer why. You have to say why you think that is the case.
Okay, wait. A quarter is bigger. Wait, what is a quarter? The quarter? No, I think that was small.
You have to skate half a lap or a quarter lap. Which would you rather do if you're tired?
Let's just do half.
No, no. Okay.
I'm
I
so
guess I
lost.
didn't.
I'm so sorry.
Okay. You're driving cars now, right?
Yeah.
If your fuel tank is half full, how is that compared to a quarter full?
If it's half full, that means I'll have that means it will last longer.
Yes. So a half is greater than a quarter.
Ah, okay.
Okay. All right. So what I'm looking for you is to fill in the blank here with maybe a word or maybe a couple of words, and then secondly, to tell me why. And we're looking at this in terms of heating ice water.
Okay,
You
the
have to type
pot
this out
of
also.
water. Okay, I will just type this in and then I will then I'll fill in the blank before I explain why. Yeah,
I'll drop this in the chat so you don't have to retype all that.
thank you. Okay, here's what I have written down so far.
All right, let's take a look here. So we're not talking about melting though. We're talking about heating. Heating. We want to use the word heating, or
I
maybe
see.
more, maybe a better word for heating is what it gets to when you're heated it all the way.
I see. Okay, so that makes more sense. Okay, now I know. So the pot with half ice in it will heat up slower because half is more than a quarter. So the quarter one will take less time to heat up. Does that make sense or am I being confusing?
Go ahead and just type it out.
Okay. Okay, this is what I've written so far. I just mentioned the same thing kind of in a way from what I last wrote. I know I can add more. I just can't think of anything else.
So let's take a look here. What you got? Okay, the pot of water with half ice will heat up slower compared to the pot of water with quarter ice because the quarter pot of ice is smaller than half. Okay, so this is we can't say that. But I
Yeah,
mean I understand what you're trying to say. Um,
that's good.
think about energy. So we want to use the word energy because and this is where it's you can also talk about like how long maybe this is okay. Maybe that is okay. I'm not convinced that we need to actually change that. So okay. All right. The second question here is for you to decide. Um, is for you to decide. Um, they're saying here, what do you think the heating curve will look like while the ice is melting and after the ice has melted? So there's really two parts to this. So it's like how quickly will the temperature change while the ice is still in the pot? So that's the first question for you to ask yourself. And you want to use words like it will change quickly, not quickly, fast, slow. What do you think will happen? And maybe think about this. If you've ever been served a beverage with ice in it,
Yes.
does the temperature of the beverage change quickly or not, or slowly?
Okay. It changes quickly because the ice is, it's frozen solid and it's cold. And the moment,
So here's what you just said. I don't, because I don't think you meant this. You said like, I bring you a glass with ice water or ice lemonade. You're saying, here's what I heard. It's cold to start out, but then a few minutes later, it's really warm.
no, it's cold to begin with, and it will finish off cold
Right.
because,
So that suggests it does not change temperature quickly with the ice. And
yes.
that's what I'm trying to get you to put a sentence together.
Oh. So the temperature will change quickly.
No, we're not saying that. If it changed quickly, you would, the ice lemonade would then be warm after a few minutes, but that's not the case.
Yeah. With ice, everything will be cold, become cold fast, and it will stay cold. But with
Okay, so we want to use a word like, so we're talking about whether how quickly will the temperature change when there's ice. It doesn't change very quickly. It's slow to change. So we're looking for some words for that here for this one.
you know what I'm gonna do after this, we finish everything. I will actually get a pot, put a half cup of ice and another one of quarter, and I'm gonna time it to see how long it takes for each of them to melt. I'm
It's a
doing
good
it.
thing. It's a good thing to do.
I need to know, and also not to mention the teacher wants to see photos, so might as well try it out if I'm not
Well,
mess.
they probably have a place where they want you to take the picture, um, which is
in my kitchen.
Yeah, it does look like they want a picture there. Goodness. Yeah.
So far, I've only written one sentence about how the temperature will be slow to change since the ice takes a while to melt. I should
Okay.
instead of a while, I should said long time for more words. I just sent in the chat what I wrote.
Okay. The temperature will be slow to change since ice takes a long time to melt. Okay. You could give an example. So an example of this is a glass of lemonade with ice remains cold. Rather, yeah, we'll just say it like that. Okay. Um, even if it's set out in the sun. All right. Now, the second question for you to answer here is what will happen to the temperature? Let me do it this way. How quickly will the temperature change once the ice is gone? So basically, you're no more ice. It's just water. How quickly do you expect the temperature to change when you're boiling the water?
I expected to like wait, what? I'm sorry. How quickly will the temperature change with?
And
So
you're and
I,
you're and you're
I
you're
sorry.
comparing this to the previous scenario, which is with the ice.
I
So
think the
you're
temperature will start to go up the moment the ice melts. Like
right. We know it's going to go up, but how quickly will it go up?
slowly. It will go up
You
slow.
you just said slowly for the previous one. Is it going to be faster or slower than the previous one? You're trying to make a comparison to that.
No, wait, it will go up faster because you're also
Yes.
heating it.
Well, you're heating them in both situations.
Yeah,
So you're
but
heating
it
in
will
both
go up
situations, but
faster.
yes. So I want a sentence that says that you do want to compare it to the previous one, saying like, something like, well, it's going to be faster than ice.
Should I also put an example about the temperature change when the ice is gone as well?
We'll have to do that.
Okay. Here's what I have written in the chat. I think I could have written something better.
Yeah, that's okay. That's a good answer here. So this is where I'm not sure exactly. Um, if you read the description here, it says uh, answer these questions to the introduction of report before you conduct the lab. Question was your hypothesis procedure one. Question is your hypothesis procedure two. Like what I'm not sure of is if we're supposed to put our answers here into this section, or if we are supposed to leave it like as the question answered.
I
So I'm
think
not
we're
sure.
gonna. I'm not sure either. I'll double check it later.
Okay. Let me just do a quick formatting thing here. So we should talk about the purpose of the lab.
Okay.
Um, what do you think they want you to learn about? We've just talked about it at length.
Um, what? I'm so sorry.
The purpose of the lab is what we've just been talking about, these answers here.
The purpose of the lab is to see how long it'll take for water to heat up when there's ice in the pot.
Okay, so the better answer here is the relationship between the quantity of ice and time it takes to boil or heat up, you know.
Yeah.
Okay, so we're going to stop here for now and take a little
Okay.
break, and then we'll get back into it. We'll make sure you're ready to do this lab right after the next lesson. So I'll see you in about 10 minutes.
All right, see you in 10
Bye.
minutes.